Good evening. So we have covered a lot of variety of SICI questions along with formulas and tricks in the last lecture. Today we are going to focus more on reoccurring deposits and installment payments. Better than yesterday. So I think close to 10 questions I have created and collected on installments and recurring deposits. In terms of theory is going to be about 25 to 30 minutes. So we'll just wait 1 or 2 more minutes for others to join. And then we start with the theory. Because the concepts are same as the last two lectures, it will not be very heavy in terms of concepts or formulas. Installments has made a comeback in CAT in last 3 years. Several questions have been asked on installments. Let us start with a theory. The concept of reoccurring deposits under CI. It is very important. The question must tell us whether it is SI or CI. If nothing is mentioned in deposits, reoccurring deposits, RDs, and installments, if nothing is mentioned, we by default assume CI. That is the standard way. Recurring deposits, installments, if nothing has been said, we assume them to be compound interest. No exceptions. Calculator will be needed for most of these questions. On-screen calculator from CAT. Chalo. So I want you to observe whenever we raise something under CI, we multiply 1 plus R upon 100. We multiply this. I'm calling it K. K is the increase factor. I want to increase something by 10%. I'll multiply 110 upon 100, or I will multiply 1.1. I'm calling it K. This is the percentage increase factor. 1 plus R upon 100 is equal to K. See, just for the sake of understanding, I'm imagining 1st of January. 1st of January, let us say 2018. You go to a bank and you make a deposit of X rupees in the bank. Now you wait for 1 year. You make another deposit of X rupees. Let us say 2019, 1st of January. You wait for another year. You make one more deposit of X rupees. It is 2020. You wait for one more year. 2021. You take away the entire amount. So question can be framed in two ways. We will tell you, or the question will tell you, how much amount you want after 3 years. This is what deposit for 3 years. This is the first year, second year, and third year. How much amount do we want after 3 years? Amount will be given, rate of interest will be given. You will be asked how much is the annual deposit. Or reversal will be, you will be told somebody deposits 30,000 or 40,000 or 1 lakh every year. How much amount will they get after certain number of years? Very rarely, in fact, I have not seen it so far, that rate of interest will be asked, because under compounding, the rate of interest gets squared, cubed. So it is not possible to solve a cubic equation in the exam. So you will be asked either the amount of deposit every year. If it is monthly, then we work in that manner. Or you will be asked what amount will you get. So either X will be the question, the deposit, or the amount will be the question. Like somebody wants to retire 5 years down the line with 5,20,000 rupees. How much money should they deposit every year at 10% to achieve that? Something of that sort. So observe the derivation of the formula now. When this X rupees goes into the bank, by the time it reaches here, it has increased the value, it has generated interest for 1 year. So this X rupees becomes X into K when it reaches here. If it was, let us say, 1 lakh rupees, interest was 10%, it will become 1 lakh increased by 10%. Now at this point, another amount is being added. X rupees are being added to this. Now this together goes on for 1 year. This is there in the bank for 1 more year. So increases by K. Look at that. Whole thing increases by K. Some another amount is added here, X rupees. Now all of this is within the bank for 1 year. So it again increases by K. Now what you have is the amount AM. So now if I expand this, see this K multiplied here, this multiplied here. See, this is K into K into K. So X into K cube. This X, the second one, is multiplied by these two when you open those brackets. X into K square, and this is multiplied. This X is multiplied with only 1. First, you write this much down. Can the value of amounts change? Can the value of installments change? Yes, you can customize this. This could be X1, X2, X3. You can change it as far as the process is concerned, it remains the same. You copy this down, comment done. I'll show you a better way to remember this. A better way to remember all of this. The concept of reoccurring deposits under CI. Comment done. K is the increase factor. K is equal to 1 plus R upon 100. K is the increase factor. Now I want you guys to look at this in a different light, because when people see installments and deposits, they freak out. I want you to observe a different approach to this. Don't look at these values. this X rupees goes into the bank and this X rupees is taken out. It comes out after 3 years. So whatever that was, X1, X2, X3, whatever that amount is, X rupees, it is in the bank for 3 years compounding. So the amount becomes X into K cube. The amount because of this becomes X into K cube. When this X rupees goes into the bank, this X rupees goes into the bank. It is taken out after how many years? It is taken out after 2 years. So this X rupees would compound for 2 years only. And when this X rupees is kept in the bank, this X rupees is kept in the bank, it is in the bank for 1 year. So this X rupees will compound for 1 year, and that is your amount. So don't look at it as separate deposits or recurring deposit. You look at it as separate account. This is account 1, account 2, and account 3. You are adding the amount of those accounts to generate the final amount. In such questions, what can change is X1, X2, X3 can change. If rate of interest changes, the whole thing changes. What kind of questions will you have? You will be told kitna amount. You'll be told 3,21,000 chahiye. Rate of interest is 8%. In 3 years, how can you do this? What is X? Or else you will be told every year somebody deposits 1 lakh rupees at 8%. After 3 years, what amount will be there? Either X can be the question, the deposit, or the amount can be the question. You can look at it as addition of 3 separate amounts, addition of 3 separate outcomes. This X rupees, when it goes into the bank, it stays there for 3 years. When this X rupees goes into the bank, stays there for 2 years, and the last one goes, it stays there for 1 year. So you accordingly adjust the amount. I hope this is clear to everyone. If you try to convert this into monthly, you will need geometric progression. Up to three deposits, 4 deposits, I've seen questions. Rarely into 5 deposits or above. Comment done. All right. So what is the concept of installment? What is the derivation? Again, I'm repeating this. In compounding, we again and again multiply this. We multiply this every time 1 year goes by. I'm calling it K. That is the increase factor. K is the increase factor. If it is 10%, 20%, 30%, you multiply K, increase has happened. Now, if let us say somebody named Rakesh goes to bank and takes a loan. So here, once a loan has been taken for Y rupees, immediate payment is called down payment. I'm not considering down payment right now. The first payment is made after 1 year. Second payment is made after 1 year. Third payment is made after 1 year. And here we say we are done with the loan. So what kind of language will be used? a loan of Y rupees, was paid back in 3 annual installments at R%. A loan of Y rupees was paid back in 3 annual installments at R%. This is also called reducing balance approach. This way of calculation is also called reducing balance approach. Please observe. When somebody has a loan of Y rupees, by the time that loan reaches here, it has been on for 1 year. So the value of loan increases by K. Somebody makes a deposit of X rupees. So the loan decreases. This is why it is called reducing balance. The loan has decreased by X rupees. This is the balance loan. Now this will carry on for 1 year. So it will again increase by K. Somebody makes a payment X, so decrease by X. This goes on for 1 more year, so into K, and somebody makes a payment and we say done. We say done. That means there is no more loan to be paid or money to be deposited. So if I open these, please observe. This Y will be multiplied with this, and this. So it will become Y into K cube. This X is multiplied by this K and this K. This will become xk square. This is multiplied by only 1k. This is not multiplied anywhere, 0. Now if I rearrange this, so this is the formula I want you guys to focus on. Write it down, comment it done. I'll give you customization of this. Write it down, comment done. This is xk square x if a down payment was made, the loan will no longer be remain Y. It will be loan minus down payment. So I want you to visualize this in another way. You don't have to go through these steps. That is pretty useless. What you visualize here is this Y rupees from here to here has been in a manner active for 3 years. So what should be the value at the end of 3rd year? The value at the end of 3rd year should be Y into K cube. Now I visualize deposits. X rupees deposit was made. What will that deposit become after 2 years? That deposit will become xk square. This X rupees deposit was made. What will it become after 1 year? It will become xk. And when the last deposit X is made, we say done. There is no time period after this. I cannot add interest on this. So we say loan should be equal to the deposits. So you have made the balance payment. This method is very effective if you have different values of x1, x2, x3. But I feel this way of writing is very neat and clear. Loan on one side and payments on the other. This is easier to work with. I'll show you CAD questions. I've kept 3 CAD questions for you based upon installments. If you want to convert this into monthly installment, let us say the rate of interest is, let us say 12% per annum. So you can say rate per month will be 1%, and accordingly you adjust. if rate of interest, let us say, is 18% per annum, the rate per month will be 3/2%. So you can divide and arrange accordingly. It could be a quarterly payment, it could be a biannual payment, 6 monthly payment. So you can adjust accordingly. You have to divide the rate of interest. We have discussed this in the last lecture, how to break a larger scheme into smaller parts. So rate of interest must be adjusted accordingly. So let me frame a small question for you. Very rarely rate of interest gets changed. I'll try to do that as well for you. Somebody has taken a loan of, let us say, 5 lakh rupees. The rate of interest first year is 10%, rate of interest second year is 12%, rate of interest third year is 15%. Random, everything is random. First installment was rupees 2 lakhs. What should be the second installment? What should be the second installment? If the third installment was rupees 2 lakhs. What should be this? In this case, I will suggest you guys, you apply this approach, the way I have derived it for you, because what is changing every year? Rate of interest. This is very effective when rate of interest is a single number. Here there are multiple values. So what we will do is, we'll go step by step. I'll focus on start and ending. This is first year, start. The loan is 5 lakh rupees. The first year is about to end. What will the loan become? The loan will become 10% higher. 10% higher amount is 5,50,000. What was done? A payment was made of how much? Of 2 lakh rupees payment was made. So the effective loan becomes 3,50,000. Now this is the second year start. Now I will need a calculator, obviously. Second year start, the loan amount is 3,50,000. I will increase that by 12%. How do you increase 12%? You multiply 1.12 to increase 12%. 3,50,000 multiplied with 1.12. So by the end of this time, it becomes 3,92,000. Now what do? Somebody makes a payment of X. So the balance becomes this. Now what do? We go for 1 year's growth. 1 year's growth is 1.15. Where have we reached now? This is the end of third year. Now can I say the last payment should balance it off? This is the last payment. This is the end of third year. This is the last payment. 2 lakh rupees should balance off the loan. So what I will do is 3,92,000 increased by 15%. This gives me 4,50,800 rupees minus X into 1.15 is equal to 2 lakh rupees. Now rearrange, move it here, subtract, and answer is ready. Minus 2 lakh. This is 2,50,800 rupees divided by 1.15 is the second installment. So if you ask me, sir, is this CAD level? Yes. So this value will be 218,086. 2,18,086. 86.95 rupees is there. So it could be 87 rupees. This is the CAD level example, guys. If I change the rate of interest and also the installment amount, I'm trying to make one point here. You should use this method only when R is changing. Otherwise, the final formula is the best way. This final formula on the right side is the best way. If you have same rate of interest, do not deviate from the path. Use that formula to get the answer. This reducing balance approach, the proper derivation approach used when R is changing. R is not the same. Comment done, let me know. Moving on. Simple interest, we'll come back to. I'll show you the formulas that I have derived for CI. I'll do it for SI. It will be easier to do this for SI because there are no powers involved. Try this question, give it a shot, take 2 minutes. Give it a try. You have to focus on what is the duration of installment, also how many installments are there. Accordingly, you will have to adjust rate of interest. Now I am looking at two different answers. See, the payment value has to be more than half of this. keep that in mind. Keep that in mind. The payment value must be more than half of this because you are paying in two equal halves. Half of this number is somewhere around 1275. So the installment has to be more than 1275 for sure. Because annual interest is 8%, half yearly. Half yearly means 6 monthly. It will be 4%. This is the loan value 2550. The payment is made in two parts. So 1.04 square. When you make the first payment, it will generate interest for one cycle, 6 months, and second payment pays off the whole balance. So 2550 into 1.04 into 1.04. On the right side, what do I have? X is common. Once you take out X, it becomes 2.04. So all you have to do now is use calculators. Perfectly fine. That is why they are given in the exam. 2550 into 1.04 into 1.04 divided by 2.04. So the exact amount comes out to be X is equal to 1352. Exact amount. The loan will also generate interest. How was this paid off? You don't have to draw diagrams always. This is where the loan was approved. Then after 6 months, a payment was made. After another 6 months, the payment was made and we said we are done. So when the loan reaches the end of the year, there are two cycles of 6 months. Don't multiply 1.0. That is wrong. Don't multiply 1.0. There are two cycles of 6 months. So it will be 1.04 square. Understand, 1.04 square is more than 1.0. We have talked about this. In compounding, when you break a larger scheme, you generate extra interest. So the exact answer is 1352. 1352 is the answer. Confirmation that the question is clear. Let us try another problem. This is a question from CAT. Not one word has been changed. Maybe around 2019 or maybe 18. Not too far. Give it a shot. John borrowed 2,10,000 from a bank at an interest rate of 10% per annum, compounded annually. The loan was repaid in two equal installments, the first after 1 year and second after another. The first installment was interest for 1 year plus part of the principal amount, while the second was rest of the principal amount plus the due interest thereon. Each installment in rupees is. Comment the answer. It is annual installment. You do not have to change rate of interest in this particular problem. Once you grasp that installment concept in the formula, these questions are going to be worth 2 steps, 3 steps at the most. Oh. Yeah, that seems more like it, yes. Half of this number is 1,05,000. The installment will be definitely above 1,05,000. So how to work with this? Visualize. A loan was taken for 2,10,000 rupees. After 1 year, a payment was made X rupees, and after another year, payment was made X rupees. All of this is of no use to you, that you are making payment of installment and the interest. That is assumed that you are making interest as well as the loan payment both. This does not need to be mentioned here. So what is happening here is this loan was active for 2 years. So 2,10,000 rupees was active for 2 years at 10%. 10%. I could write it as 1.1 for 2 years. When this payment was made X rupees, there was 1 year's time period after that. So this X rupees would generate interest for 1 year, 1.1 to the power 1. And when this payment was made, it was the end of the time period. So there is no interest for this X, that is fixed. So if I rewrite this as 2,10,000 into 1.21, 11 square, I know you know. If I take X common here, I will have 2.1. X common, I will have 2.1. This 2.1 can be cancelled 10 times. That is basically 1 lakh. This is now 1 lakh. 1 lakh into 1.21 is 1,21,000 is the installment. Now you think and tell me, Does the question anywhere say anything about CI or SI? Does the question anywhere say anything about CI or SI? Yes, it says compounded annually here. Even if this was not mentioned, installments are there. By default, it is always SI. Once it has happened in a ZAD question, after solving it on CI, none of the answers matched. Answers definite. Then it worked with SI. But otherwise, generally, installment questions are always on CI. Even if nothing is mentioned, always on CI. Everyone confirm if this is clear to you. The general formula would be, if y is the loan, y into k to the power n is equal to x into k to the power n minus 1, x into k to the power n minus 2, x into k to the power n minus 3, goes on, goes on, goes on, last value is x. Generally, if you want to create a formula like representation, this is what you will have to achieve. See, confirmations on done. Yes, if it says installments, you assume equal annual installments. Let us cover one more question and then I'll go back to the derivation for simple interest part of it. Give me a second. Look at that equation. Y into k to the power n is equal to x into k to the power n minus 1, x into k to the power n minus 2, x into k to the power n minus 3. The power of k decreases and the last value will be plus x. I have not come across any question with more than 4 installments, because anything more than 4, you will need a geometric progression. That is advanced algebra. We don't expect that here. Done. All right. Let us solve one more problem and then we'll go to simple interest. Give it a try. Take 3 minutes and try. Comment your answers. Comment answers. Yes. Good. It also matches with one of the options, so I assume correct hoga. Good. Very good. Now, Mr. Jeevan wanted to give some amount of money to his two children so that although today they may not be using it, in future the money would be of use to them. He divides the sum of rupees 18,750 between his two sons, age 10 years and 13 years respectively, in such a way that each would receive same amount at 3% per annum compound interest when he attains a age of 30 years. When we say he, we don't mean Mr. Jeevan. His two sons, when they achieve the age of 30 years, they will have equal money. And how does Mr. Jeevan want to do this? He wants to divide 18,750 rupees among the two children. So when I see such kind of question, I always think about what kind of answer am I looking at. See, for this child to reach 30 years, he has a time duration of 20 years. For this child to reach 30 years, he has time duration of 17 years. So this child has more time. So whatever money you give the younger one will have more time to grow. And I want them to have equal money. So that gives me idea. The younger child will receive less money and the older child will receive more money at this stage. right now, when he is giving away 18,750 rupees, younger child will receive less, elder will receive more, because whatever money you give younger child, that money has 3 more years to grow. So if I simply look at half of this number, that is 9, 3, 7, and 5. My answer should be below this. All the answer options are below. That is okay. That is okay. But if there was one option below, others were equal or above, I would have discarded them. So I need a number less than that. So here we are saying if the money is A, it increases by 3% for 20 years. If the money was B, it increases by 3% for 17 years. I can apply rule of indices. I can cancel this. So I'll have to subtract 17 from here. So I'll have A into 1.03 cube is equal to B. B is the money of elder child, A is the money of the younger child, and younger का answer पूछा है. Can I say A plus B should be equal to 18750? Calculator होगा आपके पास, that is fine. So here I will need a calculator and I'll put it here. This will become A plus A into 1.03 cube. We need to cancel this value on the right side and we'll have our answer. So A is equal to 18750 divided by 1 plus 1.03. We'll have a precise answer. Decimals are given up to 2 correct places. Let us correct those. 18750 divided by 8959.60. 8959.60. So I guess we'll go with this answer option. 8959.60. You can do this also. You can assume one of the values as x and the second value as 18750 minus x. Works perfect. Perfectly, yes. Confirmations on this? Now for yes. If you're joining right now or you're watching this from the middle, you need to understand the concept of percentages. That's all. This is not even installments. This is not even successive change. This is basically one person has 3 years extra for the money to grow. So A into 1.03 cube is equal to B. That's all. Now let us spend 5-10 minutes on simple interest. Now you remember, in simple interest, we don't multiply 1 plus r upon 100 to the power n. We don't do this. If I say somebody is charging 10% simple interest for 2 years, so we add 10%, 10%, we say 20%. If somebody is charging 10% this year, next year the person is charging 12%, next year 15%, we add. Simple interest percentages are added. You don't multiply with a power. Simple interest, you don't multiply with a power. So how does reoccurring deposit look like? Let us say rate of interest is r percentage. Somebody makes a deposit of x rupees in the bank. We wait for 1 complete year. Another deposit is made. We wait for another year. A deposit is made. And after 1 year, we take away the amount. So what will the formula look like? Now you can do this in 3 steps. This X rupees was there in the bank for 3 consecutive years. This X rupees will increase by R percentage 3 times, R plus R plus R. So 3R upon 100. It becomes very easy for you to work with. This X rupees goes into the bank and stays there for 2 years. So this increases by R plus R. And the last one is in the bank only for 1 year. So it only increases by R. That is the amount you will take home. So here, this number n is not in the power, but in front of R. See, in the previous case, if you look at this number was in the power, the number of years. How many years is the loan taking to mature? 3 years. So 3 was in the cube format. In this case, 3 will be in front of R, because here R is not multiplied, R is added. Comment and let me know. Good. Very straightforward, nothing fancy, nothing heavy. Very straightforward. In compounding, the 1 plus R upon 100 is multiplied. In 2 years, you will have a square. In 3 years, you will have a cube. In simple interest, we don't multiply the increase factor. What we do is we add R percentage. Do you remember the concept of simple interest? If it is 6% for 4 years, it will be 6 plus 6 plus 6, 4 times, 24%. It will not be 1 plus 6 upon 100 to the power 4. That is compounding. In simple interest, it gets added, not multiplied. So let me cover the installment formula. You'll find it to be easier. Here, please observe. If right now somebody takes a loan of Y rupees, and it is paid back in installments of X, and X. And here we say the payment is done. So we can directly jump to the formula in this manner. This loan was active till this point for 3 years. So the loan Y would have increased 3 times. So it will not be 1 plus R cube. No, it will be 1 plus 3R. When this payment was made, there were 2 years after this. So this payment will generate the interest for 2 years. This one will generate interest for 1 year. And when this payment is made, we say no more, done. This is under CI, under SI. What does it look as compared to under CI? This is what it looks like. So if you observe these side by side, maybe something will click. Look at this. 3 is in front of R as a multiple. 3 is in the power of R. 2 is in front of R as a multiple. 2 is in the power. So under compound interest, rate of interest gets multiplied. Under simple interest, it gets added. In the first lecture of SICI, the session 1, I had shown a derivation, and the sentence was, Under simple interest, money increases through additions. Under compound interest, money increases through multiplications. So there is one question online which is being solved incorrectly by many people. So I'll just try and explain that question to you, and I will probably solve it for you. I've done that in the uh, WhatsApp group that we are all part of. Comment done for the theory here. A reducing balance approach cannot work on this. This is not reducing balance approach. Let's move on. Now this is a question doing rounds online, and 8 out of 10 people on both sides of the screen are solving it incorrectly. A loan was taken for 10 rupees. Somebody took a loan of 10 rupees and made a payment of 1 rupee every month. 1 rupee every month. 1 rupee per month for 12 months under the SI scheme. The question is, how much is the rate of interest? In SI, because rate of interest is added, see here it is added R plus R plus R, R plus R. So I can ask for the rate of interest. It is not possible to ask R here or here. It is becoming cube. Cubic equation कौन बनाता है? So give it a try. Take 3 minutes. Give me an answer. A loan of 10 rupees was taken at the start of the year. Let us say 1st January. And then the end of January, end of February, end of March. At the end of every month, 1 rupees was paid back. At the end of December, when the last rupee was paid, we said loan is over. So what is the rate of interest? How much is the rate of interest? At the end of January, February, March, at the end of every month, 1 rupee is being paid in the bank, or the loan is being paid back. What will be the rate of interest? It's a very interesting question in terms of calculations, in terms of framing. When the question is what is the rate of interest, it is assumed it is per annum. The answer will be per annum. Comment answers. Once you understand the concept, this is not an advanced question, guys. R will be definitely a decimal. Yes. So please observe. In this case, I am not using small r as a variable. Small r I'm assuming is annual rate of interest. I'm using capital R. Capital R is per month. So the overall should be 12 into per month is equal to annual per annum. I'm using this variable R, capital R. Capital R is for 1 month. This 10 lakh rupees loan was paid back after 12 individual months. So this is supposed to increase 12 times. 12 times R. When at the end of January you make first payment, that X rupees will increase 11 times. X rupees is 1 rupee here. X is 1 rupee. The installment is 1 rupee. That will increase 11 times. The payment you make in February end or on the February end, at the end of February, will increase for 10 times. Similarly, the next one will increase for 9 times. The one you make in November, it will increase for 1 month, and the one you make at the end of December will not increase. It is 1 rupee. So on the left hand side, what do we have? 10 plus. When this 10 is multiplied inside, you can cancel 0 or you can leave it as it is. It is 120 R upon 100. I've just multiplied 10 inside. Now do you see? This is multiplied here, 1 rupee, 1 rupee, 1 rupee, 1 rupee, 1 rupee. So I will have total 12 rupees plus. What is this? 11R plus 10R plus 9R. So what I have is 11 plus 10 plus 9. This is R. So 1. R upon 100. So here, if you see, this is called addition of natural numbers. It can be rewritten as, this is last term, 1 plus 2 plus 3, n, this last term n. This will be 12 into 11 upon 2 into R upon 100. Just solve this and you have your answer. You transfer, this is cancelled, this is cancelled. This is 66 R upon 100. This 10 will be moved here. This will become 2 rupees. Let me switch off the camera. I need more space. So what you will have here is, please observe, this goes on the left side. It will become 120 minus 66 upon 100 R is equal to 2 rupees. That is, R is equal to 200 upon 54. And this is interest for only 1 month. 1 month. So what is the annual interest? 12 times. That is okay. Answers are expected to be decimals. That is fine. The question was framed in that manner. So 200 into 12 divided by 54. So 44.44 percentage is the interest, guys. It's a very steep interest, I understand. 44.44 percentage is the interest. A very steep number, a very large number. If the payment was made in 11 months, the interest will be lesser. Can the payment be made in 10 months? No. The total payment would always be more than the initial loan. 44.44%. Look at the calculation. Confirm your calculations. Chalo, moving on from this, moving away from this. Give it a shot, give it a try. Take 2 minutes. So well, not exactly a installments based question. If you observe, we have talked about this. Under compounding, the amount at the end of the duration becomes the principal for next. Some money, a sum of money amounts to this in 3 years and this in 6 years. So we can say 10240 when increased 3 times becomes 14580. So what is the value of k cube? So right now, if you have access to a calculator, all you have to do is divide these two numbers, 14580 divided by 10240. So this becomes, the division of these numbers becomes 1.423. Now see, now observe, slow down. In 3 years, you have grown 42.3 percentages. If 15 was the answer, in 3 years, you will grow more than 45 percentages. Not possible. If 10 was the answer, you will grow, please observe, we have talked about this, 1.1 cube is 1331. We have done this many times. In 10% or on 10%, you will grow 33.1 percentage. We are growing 40%. Can't be the answer. If this can't be the answer, this can't be the answer. The only answer possible is B, Bombay. Only answer possible is B, Bombay. Other way to approach the problem would have been k cube is equal to 1458 divided by 1024. If you pay close attention, if I cancel 2 from both, that is 729 by 512. What is this cube of? This is the cube of 9 upon 8. So what is 9 upon 8? It is 1 extra on 8, which is 12.5% growth every year. So I wanted to observe, you could come to this step directly. You could come to this step directly if you pay attention to these values. Now, if you see, cancelling those zeros, cancelling those ratios, you directly get cube of 9. Cube of 9 upon cube of 8. That is 1 increase on 8, 12.5% increase every year. Confirmation on the approach. What I was trying to do with decimal was, I was trying to see which of these options best fit. 10% was not enough. 10% growth back to back twice, thrice is 33.1%. 15% growth 3 times will be more than 45%. So 10% is falling short, 15% is more, 9.5% will never match. The only possible way is answer option B, 12.5%. And then with a proper approach, I've also proven that the ratio between numbers is 729 by 512, which is cube of 9 and cube of 8. Try this. A man invests a certain amount at 6% per annum simple interest and another amount at 7% simple interest. His income from the interest after 2 years was rupees 348. The ratio of first amount to second is 4 by 3. The total amount invested is. Directly, very straightforward question. No need to think too much. Here, the word uses amount and not the sum. Think, answer. So here, if you pay attention to the language of the problem, the amount is invested in a certain manner, 6% per annum simple interest, 7% per annum simple interest. Total interest after 2 years is rupees 348. The ratio of the first and second amount is 4 by 5. What is the total amount invested? As soon as I hear this sentence, the total amount is 4 by 5, the total amount must be a multiple of 9. So it makes me feel the answer should be C, or else there is no answer, because these are not multiples of 9. So I'll just check this, because if I say 4 and 5, total is 2700, 300 each. This becomes 1200 and 1500. So 1200 rupees generates what? 6%. For how many years? 2 years. 1500 generates what? 7%. For how many years? 2 years. I have to just confirm, does it match? Does it become 348? If it matches, my answer is ready. Otherwise, the answer would be none of these. So two zeros are gone, two zeros are gone. This is 12 into 12, 144, and this is what? 30 into 7, 210. That becomes 354. Does it match with 348? No, it does not. Just confirm the calculation. 1200 at 6% for 2 years. 0 cancel. 12 12 144. 1500 15 0 cancel. 13 to 7 210. 354. No, it does not match. So answer would be none of these. The answer would be none of these. Yes, confirmation on this. This is a very easy question you already answered. Try this one. Again, cat and cat plus level. Take 3 to 4 minutes and solve. To start a new enterprise, Mr. Yogesh has borrowed rupees 60,000 from two money lenders with interest being compounded annually to be repaid at the end of 2 years. Mr. Yogesh repaid 38,800 rupees more to the first money lender as compared to second money lender at the end of 2 years. The first money lender charged an interest rate which was 10% more than what was charged by second money lender. If Mr. Yogesh had borrowed rupees 30,000 from each at their respective initial rates for 2 years, he would have paid rupees 7,500 more to the first money lender compared to second. Money borrowed by Mr. Yogesh from the first money lender is. So here you are dealing with three variables. One is money taken by first, borrowed from first, money borrowed from second, and the rate of interest. You are dealing with three variables. You will have to you will have to, in this case, either assume numbers for A, B, or R, or work around some solution. I'm starting with this question in the reverse order because here it says when Mr. Yogesh takes equal sum 30,000 from both, so A and B both are cancelled. So first borrower is giving 30,000 to Mr. Yogesh. Second one also gives 30,000 to Mr. Yogesh, and there's a 10% gap. See, if this is increased by R 2 times, this is increased by R plus 10 2 times. Compounding bola na, the question is compounded annually. And how much is the gap between the two? The gap between the two is 7,500. Now here I will suggest you use your calculator. See, I can convert this into quadratic. That will be waste of time. You check values of R. Take R is equal to 5% till 15% and see if the gap can be created. See, I'm taking what common? I'm taking 30,000 common. I'm checking for 5%, just 5%. So the first one becomes 1.15 square minus 1.05 square. My job is to match the 7,500 value. So when I calculate this, I am getting 6,600. So 5% does not match. I am getting 6,600. I need more. If I take R is equal to 10%, this becomes what? 30,000. I'm testing numbers. If I put R is equal to 10%, this becomes 1.2 square minus 1.1 square. You can use calculator, you can use A square minus B square, totally up to you. Even now, this is 6,900. 10% is not enough. I'm using 15% now. I'm just testing. 15%. So this becomes 1.15 square and this becomes 1.25 square. If you don't want to do this, you can create a quadratic and solve. Even with 15%, I'm able to reach 7,200 rupees. It goes beyond 15%. If I make it 20%, it matches precise. R is equal to 20% matches precisely. 30,000 into 1.3 square minus 1.2 square. So if you are more comfortable, you could put 10, 20, 30 and check. Otherwise, you can always solve this quadratic equation. So I've tested for 5, 10, 15 and 20. R is equal to 20% matches. Once you know the value of R, I will say go with answer options, guys. Go with answer options. What is the gap between the two payments? 38,800 rupees more were paid to the first one. So if I go with answer option, let me test this one. 40,000 are borrowed from the first person, 20,000 from second person. R is 20%. So what is the payment here? It is 30% square. It is 20% square. Does the subtraction match? If it does not, then I'll go for the next number. That is the question, guys. 40 into 1.3 square minus 20,000 Yes, it matches precisely. So this is your answer. Why did I start with such a large number? Because the gap is also very large. There's a gap of 38,000 rupees for 2 years payment. 38,800 matches in this regard. No, no, it is highly unlikely you will have value of R in the decimal. It might be 12%, 13%, 14%, but in that case, it is anytime better than actually solving the large equation. One way I could reduce the calculation to some degree, I'll add extra screen to this. I cannot come back to the screen. I cannot look at your chats right now. Once you reach this stage where this is R plus 10 upon 100 square minus 30,000 into 1 plus R upon 100 square is equal to 7,500. So you see, this is directly 4 times. This is directly 4 times. So 4 into A square minus B square. So what is A minus B? This is whole A, this is whole B. What is A plus B? So here also, if I transfer this on the right side, this is what? This is what? 1 by 10. So if I transfer this, 2.5 is equal to 2 plus 2R plus 10 upon 100. If I transfer this, 2R plus 10 is equal to 0.5, that is 50. So R is equal to 20. What clicked, what I observed was I'm looking at 30,000 into x square minus y square. See, I was apprehensive about solving a quadratic equation, but if I look at this, when I subtract x minus y, the value of r gets cancelled. It is no longer a quadratic equation. Make sure you copy this down, because once I click next or once I shift from the screen, I cannot come back to it. Moving on. Try this, go on. Mr. Mishra invested rupees 25,000 in two fixed deposits X and Y, offering compound interest 6% per annum and 8% per annum respectively. If the total amount of interest accrued is in the 2 years through both fixed deposits is rupees 3518, amount invested in scheme X is. You can use options very well in this scenario. Otherwise, you'll have to again form two equations. What will the equations look like? A plus B is equal to 25,000. On scheme A, the earning is 6%. So 1.06 square minus A, that is the earning. On scheme B, earning is 8%, 1.08 square minus B, that is 3518. So you are expected to solve these two equations, find A, that is your answers. The investment in scheme X, that is A, that is your answer. Other ways you go with numbers. If I imagine it is 12,000 being invested, the other must be 13,000. What is the interest rate? 1.06 square minus 12,000 plus 1.08 square minus 13,000. So you can do this. If the answer matches, your job is done. Otherwise, go to the next option. Out of these, I feel A and C are easier to check. This is 1438.2, and the next one is 2163.2, addition of both. This crosses the 3,601 rupees. I need lesser interest. Lesser interest would mean more money on the lower side. This is lower interest value. The more money should be on this side. Let me check 15,000. 15,000 into 1.06 square minus 15,000 is the interest. That is 1854 rupees. 10,000 into this. That is 1664. I think this matches perfectly. Yes. This is better any time than solving those tedious equations. How did decide after checking the first option that I need a larger number? Because I'm falling short of the interest deadline. I'm getting more interest, so I need to decrease that. So I should add money on the lower side where we have lesser interest. So money should be added to first scheme. Confirmation on this? Give it a try.
In the beginning of 2004, a person invests some amount in a bank. At the beginning of 2007, the accumulated interest is rupees 10,000. At the beginning of 2010, the accumulated interest becomes 2,500. The rate of interest is being compounded annually, and the annual rate is fixed. What is the principal amount? So I'll give you, let us say, 2 to 3 minutes for this. Try. Okay. So if you notice, there is a pattern here. You look at the time gap. Deliberately, what is being done? Interest value is being given to you. So if I was to approach this question, I'll first pay attention to the year gap. See, beginning is 2004. Then the next hint is 2007, and the next hint is 2010. Deliberately, a gap of 3 years has been kept. So I'm saying 1 plus r upon 100 cube is equal to k. 3 years growth is equal to k. So principal into k, that is this duration. It has become principal plus 10,000. A interest of 10,000 is generated. Now this becomes the principal for the next years. P plus 10,000 into K. That is 3 years. This is worth 3 years growth. That is principal plus 25,000. The total interest becomes 25,000. Total interest becomes 10,000. All I need to do is create a ratio. I don't even need to find the value of K. If I do this, I have P upon P plus 10,000
is equal to P plus 10,000 upon P plus 25,000. Don't even think about multiplying across. You will generate large equations. Do you remember ratio, proportion, component of dividendo? Subtract. You bring it down and subtract. So it becomes P upon 10,000 is equal to, bring it back and subtract, P plus 10,000 upon 15,000. 1,000 cancelled. You want to cross multiply, do that, or you can say this is 1.5 times. 1.5 times. So P into 1.5 is equal to P plus 10,000. Transfer this. It becomes half P is equal to 10,000. So P must be equal to 20,000. Or you could have replaced these answer options at this stage in this equation, verified. Componendo and dividendo only says one thing. Whatever change you apply on one side must appear on the other side as well for the value to be balanced. No, interest accumulated is 10,000, 25,000. That's it for today. I have few more questions on SICI. So we will have a fourth session on SICI. We'll add one more session.